Welcome to HPC News Bytes, a weekly show about important news in the world of supercomputing, AI, and other advanced technologies.
Hi, everyone. Welcome to HPC News Bytes. I'm Doug Black of Inside HPC, and with me is Shaheen Khan of OrionX.net. The big news for us to talk about, of course, is that Groq and Nvidia on Wednesday announced a, quote, non-exclusive licensing agreement with the deal estimated at about $20 billion. Top line, the deal is generally viewed as a move to bolster Nvidia's real-time inference strength, something Shaheen will elaborate on in a moment. In addition, Groq's founder, Jonathan Ross, President Sunny Madra, and other senior managers at Groq will join Nvidia. And here's a very interesting part of this whole story. This is not an acquisition. In fact, Groq will continue on as an independent company along with Groq Cloud. As for the structure of the licensing deal, Reuters reported it is similar to other deals by large tech firms, possibly intended to avoid antitrust regulatory interference, something Nvidia may be gun-shy about after its attempted acquisition of ARM several years ago.
The news is getting a lot of attention, and despite the big dollar value, I don't see it as that significant. So let's unpack it into several dimensions. The deal structure is reminiscent of what Nvidia did with Fabrica a few months ago. Get the intellect and the intellectual capital and leave the rest behind. They also license the IP, as you mentioned, versus acquiring it, which makes it easier to pass regulatory requirements. And leaving Groq's cloud business behind avoids friction with their cloud customers while creating a new neo-cloud customer. The deal also led to a lot of discussions on the merits of GPUs versus ASICs, training versus inference, and how the news of Google TPUs being considered by the likes of Meta may have compelled Nvidia to move in the TPU direction. After all, Groq's co-founders had been at Google. The amount of money involved in the Fabrica deal was $900 million, already quite a lot of money. And this is $20 billion, and presumably a third of Nvidia's cash reserves, but quite affordable for Nvidia nevertheless, and the stakes are high. Given the relative small number of people moving over, Groq is reported to have around 500 to 600 employees, and not all of them are moving to Nvidia. The acquisition reminds me of Facebook acquiring WhatsApp for $19 billion. That was many years ago, so even bigger dollars in relative terms. There have been bigger deals in tech. For example, Microsoft Activision Blizzard for $68.7 billion, Dell EMC at $67 billion, AMD bought Xilinx for $50 billion, IBM bought Red Hat for $37 billion, and several others. Obviously, all developments in the market have some impact, but Nvidia already announced an inference-focused accelerator that we covered here, the Rubin CPX chip. And Nvidia has a commanding lead in its ability to ship hardware in substantial volume and in software and ecosystem. So I see this not as an urgent competitive response, but a nice addition of IP and talent to the arsenal, to be used where it fits, and good preparation for the future as AI evolves. Now, the Groq chip is called a language processing unit, in part because it is optimized for LLMs. I expect we will hear more about how NVIDIA will use some of the concepts in future generations of CPX, which was also built as an LLM-focused chip. Riding the LLM surf makes sense, as does a bigger nod to streaming-focused data flow concepts that show up in many accelerators now, including Groq. But it's a double down on LLM-focused hardware versus a qualitative change. While I expect NVIDIA to tell us more about chips optimized for agentic AI, this acquisition does not talk about that either. Ultimately, AI needs a few more big step functions, like deep neural nets for training and large language models for generative AI. When that next step happens is unpredictable, and that unpredictability is the real cause of the industry's worry about an AI winter. And that next step may need a chip optimized all for itself.
There is, as usual, a lot of quantum news. We'll mention a few focused on integration of quantum into HPC and building national infrastructures. IonQ and South Korea's KISTI, K-I-S-T-I, plan to integrate a 100-qubit system into KISTI's Hang supercomputer to create the country's first on-site hybrid quantum classical environment for research into such areas as healthcare, finance, and materials science. In Europe, CESGA in Spain, CESGA, is working with telco company Telefonica and the European quantum computing vendor IQM to integrate a 54-qubit IQM system with the Finisterra 4 supercomputer. And on the defense side, Inflection in the U.S., formerly called Cold Quanta, received a $2 million contract from the U.S. Army to develop quantum-inspired machine learning for navigation in GPS-denied environments, using advanced sensor fusion and CUDA-Q, Nvidia's programming platform for quantum classical applications.
The quantum computing industry has ways to go, but it's sounding more confident, bringing roadmaps forward and talking about quantum speed advantage in a real way before 2030 and maybe even as early as next year. To do that, it needs to make progress towards scale and fault tolerance, which require fidelity and control besides error correction. Singapore's so-called quantum ecosystem, comprised of A*, NUS, and NTU, and Keysight, announced a 5-year partnership to co-develop control technologies for high scale. The goal is to standardize design, testing, and cryogenic measurement so experimental systems can become manufacturable platforms. Riverlane introduced what they called an adaptive hardware decoder for real-time quantum error correction. Error correction needs to minimize the number of physical qubits to form a fault-tolerant logical one, and to be real-time. The Riverlane technology aims to adapt to correlated noise to improve the physical-logical ratio and to do it all in under a microsecond. On applications, Xanadu published a quantum framework to accelerate quantum chemistry, which can be used for drug discovery, and QubitSolve received an NSF grant to advance quantum computational fluid dynamics.
Speaking of NSF, earlier this month, reports emerged that the Trump administration plans to dismantle the U.S. National Center for Atmospheric Research, NCAR, a major climate and weather research center funded by the National Science Foundation. The news was announced on December 16th on Twitter X by Russell Vought, director of the White House Office of Management and Budget. Vought reportedly described NCAR as, quote, one of the largest sources of climate alarmism in the country. Naturally, the folks who work at and run NCAR oppose the decision, pointing out the significant climate work NCAR has done since its founding in 1960, including, for example, modeling and predicting wind shears being associated with lethal airliner crashes.
This news is the latest in a series of budget and staff cuts that show how federal government funding of research has changed significantly this year. Proponents of the cut argue that NCAR has become too much of a political activist, and any vital weather activities can be moved to other parts of the massive government bureaucracy or can be added again later and more efficiently. Opposing the decision are critics who see the closure itself as politically motivated. And then there are scientists and local leaders who have warned of consequences for public safety because of reduced ability to predict and prepare for severe weather, loss of essential data, and ultimately a setback for U.S. scientific leadership. All right, that's it for this episode. Thank you all for being with us. Thank you for being with us all year. Happy holidays, Happy New Year, and looking forward to another year with you next year.
All the best in 2026.
HPC News Bytes is a production of Orion X in association with Inside HPC. Shaheen Khan and Doug Black host the show. Every episode is featured on InsideHPC.com and posted on OrionX.net. Thank you for listening.